Now that we understand the difference between time domain and frequency domain representation, we can ask the question, what is a filter? A filter is a circuit that removes or filters out a specified range of frequency components. In other words, it separates the signal spectrum into frequency components that will be passed and frequency components that will be blocked. If you don't have much experience with frequency domain analysis, you might still be uncertain about what these frequency components are and how they coexist in a signal that cannot have multiple voltage values at the same time. Let's look at a brief example that will help to clarify this concept. Let's imagine we have an audio signal that consists of a perfect 5 kHz sine wave. We know what a sine wave looks like in the time domain, and in the frequency domain we will see nothing but a frequency spike at 5 kHz. Now let's suppose that we activate a 500 kHz oscillator that introduces high frequency noise into the audio signal. The signal as seen on the oscilloscope will still be only one sequence of voltages with one value per moment of time, but the signal will look different because its time domain variations must not reflect both the 5 kHz sine wave and the high frequency noise fluctuations. In the frequency domain though, the sine wave and the noise are separate frequency components that are present simultaneously in this one signal. The sine wave and the noise occupy different portions of the signal's frequency domain representation as shown in this diagram, and this means that we can filter out the noise by directing the signal through a circuit that passes low frequencies and blocks high frequencies.